Rolle's theorem and the mean value theorem are fundamental concepts in calculus that relate to the behavior of functions and their derivatives on closed intervals. They both help establish important properties of functions and have applications in various fields of mathematics and science. Rolle's theorem. Rolle's theorem is named after the French mathematician Michel Rolle. It states the following. Conditions for Rolle's theorem. 1. The function f(x) must be continuous on the closed interval from a to b. 2. The function f(x) must be differentiable on the open interval between a and b. 3. f(a) equals f(b), meaning the function has the same values at both endpoints of the interval. Conclusion of Rolle's theorem. If these conditions are met, then there exists at least one point C in the open interval between a and b, where the derivative is equal to 0. In other words, there is a point within the interval where the instantaneous rate of change of the function is 0. Geometrically, Rolle's theorem essentially states that if a continuous function starts and ends at the same point on a closed interval, it must have at least one point within the interval where the tangent line is horizontal. Mean value theorem, MVT. The mean value theorem is a more general theorem that builds upon the concepts of Rolle's theorem. It was formulated by the French mathematician Augustin Louis Cauchy and can be seen as an extension of Rolle's theorem. Conditions for the mean value theorem. 1. The function f(x) must be continuous on the closed interval from a to b. 2. The function f(x) must be differentiable on the open interval between a and b. Conclusion of the mean value theorem. If these conditions are met, then there exists at least one point C in the open interval such that f prime C equals f b minus f a over b minus a. In other words, there is a point within the interval where the instantaneous rate of change of the function is equal to the average rate of change of the function over the interval. The mean value theorem has important practical implications. For example, when a car starts from its initial position and travels from time a to b, the average speed is the distance traveled divided by the time taken. This theorem establishes a relationship where the average speed, which is the ratio of distance traveled to time elapsed, is equal to the instantaneous speed at some specific moment. The mean value theorem ensures that there exists a time c between a and b where the average rate of change and the instantaneous rate of change are equal. This helps us better understand the relationship between position and velocity and aids in calculating the instantaneous rate of change. Thank you.